So, with this, I would like to invite to the stage Mark Almlie, who will tell about electron in the electric field.
So my presentation is an electron in an electric field with electrochemistry with arbitrary molecules.
You can use it, yes.
Okay, so so these are some important variables that I used. X var is the width of the electron wave packet, the mass. These are all in atomic units. The mass is just 1. The initial position is just where I started it. So wave packet, this is basically a copy and paste from an earlier presentation I gave, just to make sure y'all know what how the MATLAB program models the electron. The square root of dx essentially defines the one-dimensional space this is taking place in. And then the next part is the plane wave, how it actually propagates. And then the next part is the Gaussian. It defines the shape of the electron. And then the final part is normalization, making sure that the area under the electron is equal to 1. And then so other important parts I included how I actually modeled the electric field and atoms, molecules I mean. So it just said zeros for one part, and then this part this part of the space has a value of 1, this part of the space has a value of 0, and so on. These are very generalized. And then then what I did is I increased the slope of the electric field each time. So this first run I did was no electrical field, and oh, they're not running.
Describe the words. You don't have time to fix.
The electric field just basically, well, it just expanded into the electron, and some of it, into the molecule, and then some of it happened to pass over onto the right side of the screen into the second molecule. And then this one actually has a YouTube link, so if you really want to see it, you can go check that out. And that basically did the same thing. However, some of it moved to the right more and more, and then so as I increased the slope, it got faster and faster. However, the movies aren't working, which was the main point of these slides. And then this one, basically, it all ended up moving over towards the right, and actually, maybe in the last one as well, it overcame the second molecule and just continued on moving into space. However, the simulation it stopped at the edge because the MATLAB system would have it come back on the other side if it weren't for my electrical field acting as a sort of barrier from that. And so, in summary, increasing the electric field increases the rate at which the electron propagates, and if the electron field is too powerful, it'll escape and go to the side. This was just sort of a general example of how an electric field affects an electron can be applied to a variety of situations.
Okay, let's thank Mark. And just in case